Okay, so let's see how you're doing so far on this. What's the relationship between these two angles? They have to add up to 180. So 4x plus 5 plus 10x plus 7 has to add up to 180 degrees. Same picture as that last problem, but we chose two different angles, so it's a different relationship. So what's next? Okay, so we combine 4x and 10x make 14x. We combine 5 and 7 plus 12. Then what? Subtract 12. 14x equals 168. And then divide by 14. X equals 12. Now what? Perfect. We substitute that in for x. So 4x becomes 4 times 12 plus 5. So 4x is 4 times 12 is 48 plus 5 is 53. You are correct. And then this one, 10 times 12 plus 7. 10 times 12 is 120. Plus 7 is 127. Now, just to double check, those should add up to 180, do they? Yes, they do. They do add up to 180, so we're relatively sure that is a correct answer. We're about 2 minutes early for our break, but we're going to go ahead and do that. Let's come back at 9:28, and we'll start up again. Okay, it's that time, so let's go ahead and get rolling again. We're going to continue with geometry, but we're going to move on from angles, and we're going to step back into those rectangles again. Let me try that again. You will find that whenever we do anything visual where I have to draw pictures, it's going to require an incredible amount of imagination on your part, because there's a reason why I'm a math teacher, not an art teacher. Let's just put it that way. In a rectangle, we have our length and we have our width. And of course, the opposite sides are the same. So this side has to be the same as the top side, and this side has to be the same as the left side. Opposite sides are equal. One of the things we will define about a rectangle is something called the perimeter. The perimeter is the distance around, and we talked about this briefly in the last unit just as a use of a formula. So the distance around it can be found by adding up all the sides. So for a rectangle, that perimeter, which we're going to abbreviate with a P, is just the length plus the width plus the length plus the width. If we go around the rectangle adding up the sides. Now as we look at this expression, this formula here, we can simplify that quite a bit. We can combine L and L to get what? 2L. Okay, think of it as 1L and 1L, or like an inch and an inch. We don't say 1 inch always, but an inch and an inch makes 2 inches. And then, of course, W and W makes 2W. I know, I have to ask the hard questions, don't I? So anyway, the perimeter is equal to 2L plus 2W. If I give you a rectangle, and let's say that I tell you that the width is 5 inches and the length is 9 inches, we can find the perimeter. 2 times 9 plus 2 times 5. And then we just go ahead and do our order of operations on that expression. 2 times 9 is 18. 2 times 5 is 10. 18 plus 10 is 28. And of course, that's inches. Now, some of you have probably seen an alternative formula that actually is a little quicker, and it's the one I use. A couple of you rattled off the 28 pretty quickly, and I suspect this is what you did. You add the length and the width, and then you multiply it by 2, which is a little bit quicker. So 5 plus 9 is 14, times 2 is 28. That formula works just as well. For what we do in here, we're going to usually use this formula just because it's a little bit quicker to use. This one would require us to solve that for either one of those. You'd have to distribute the 2, and you're going to end up with perimeter is 2L plus 2W anyway. So it's just going to be more efficient for us to start with this formula when we're doing the algebra. If you're given the length and width, by all means, this formula is quicker. Feel free to use it. So similar to a question we had on the test, if I give you a rectangle where the width is 11 feet, we do not know the length. But I tell you that the perimeter is 50 feet. How do we find the length? Well, we have our formula. P equals 2L plus 2W. And we plug in the numbers. Do we know P? Yes. Yes, that's the 50. Do we know L? No, so that's going to stay 2L plus 2W. Do we know W? It's 11. So 2 times 11. So yeah, you're right. The next thing we would want to do is come back and combine that. 2 times 11 does make 22. And now we can solve for L. What are we going to do next? Subtract the 22. So 28 equals 2L. And then divide by 2. So 14 equals L. Now we have to go back and make sure that that is answering what the question is asking. L is the length. That's 14 feet. Is that what we were asked to find? Yes. So we are done. We also briefly mentioned another characteristic of a rectangle, and that was the area. Now, we had mentioned length times the distance, but since we're dealing with strictly rectangles, we're going to use length and width. So A for area is simply equal to length times width. So if I give you a rectangle where I state that the width is 6 inches and the length is 14 inches, I would find the area by doing 6 times 14 or 14 times 6, either one, doesn't matter, which is 84. Now we do have to combine inches times inches makes inches squared. So 84 inches squared, or 84 square inches. If I give you a rectangle where I say the width is 5 feet, but I do not give you the length, but I say that the area is 80 square feet, well, the area is length times width. Do we know A? Yes, that's the 80 square feet. Do I know L? Nope, that's what I'm looking for. Do I know W? Yeah, that's 5 feet. So to solve, I have to divide by 5 feet. So that divides out. So now we divide this. 80 divided by 5 is 16. Feet squared divided by feet is just feet. So the length is 16 feet. Now from now on, I won't be including the units in the formulas, the feet squared and the feet. I wanted to include it in the first couple of formulas just so you see that the units do work out. And technically that's one of the strategies for checking to see if you're doing it correctly, is to use the units and make sure the units come out to the right unit when you multiply or cross them off, cancel them out with division or whatever. Just for the sake of speed and simplicity, right now we're less concerned about the geometry and we're more concerned about the algebra and working with the formulas and variables. And of course we can go to the next step. So let's take that rectangle. So this is a rectangle. We're just looking at it from kind of above and off to the side a little bit. If we take that rectangle that we created and we pull that, oops, get back here. Remember, we created the rectangle by taking that line segment and pulling it perpendicular to the original direction. If we take this and pull it perpendicular to both of those original two directions, we create, if you think of this as leaving a trace as it goes through space, we create a box. We have built a volume. And that volume is equal to, it depends on the area of that rectangle, what we would call the area of the base, times whatever distance we move that area, which is generally referred to as a height. Now for simplicity, for a box, this formula, volume is equal to area times the height, or area times the distance, is for any general shape. Since we're dealing with just a box here, we can go to a more specific formula. The volume is length times width times height. Note that length times width is just the area of the bottom of that box. So of course, V is equal to LWH. This is going to be the abbreviation. Now if you're struggling to draw this out, by the way, instead of drawing it the way I do, a simpler way to do it is to just draw a rectangle. And to draw another rectangle slightly offset. You can connect the corners. It's not pretty, but it works. So there's a box. And let's say that we are told the length of this box is 9 inches. The width of this box is 5 inches. And we do not know the height of the box. But we are told that the volume of that box is 270 cubic inches. So V equals LWH. Do we know V? Yep, that is the 270. Now I could put in cubic inches and the units would work out, but we're going to leave them off just to work with the numbers here. Do I know L? Yeah. Yep, 9 inches. Times, do I know W? Yep, 5. And H? That's what we're looking for, is H. Good. So now before we start to solve, we do have to combine. So we've got 9 times 5, which is 45. So 270 equals 45 times H. And then divide by 45. H equals 6. So the height of this is 6 inches. Any questions?
If we do write down, if we're doing our own work, is it okay if we can show it to you and
That is fine, yeah. I just don't kind of started leaving it off here because it tends to confuse people with it in there. But yeah, technically if I were doing this out, I would do 270 inches cubed equals 9 inches times 5 inches times h. And when I combine these, I would get 45 inches squared times h. And then when I divide it out, I would divide out the 45 inches squared, leaves me with h. Here, 45 inches squared. 270 divided by 45 is 6. Inches cubed divided by inches squared is inches. So the units do work out. Now, when we're dealing with perimeters and areas, we're not always going to deal with nice, pretty, perfect little rectangles. We can end up with more complex shapes like this. So let's say that this is 20 inches and 16 inches. And let's say that I am told that this is 5 inches and 8 inches. To find the area of this, there are two methods. Method 1 is to cut it into smaller pieces, smaller rectangles, and add them together. So let's start out by doing it that way. To cut this into smaller pieces, there's really two choices. I can cut it across here, and I have two rectangles, or I can cut it vertically down here and have two rectangles. Any preference as to whether I cut it horizontally or vertically? Okay, well, since the line's in there right now, we'll leave it like that. So I've got two pieces I have to find. Piece 1, this is 16 inches, but I need to know this dimension here. What's that going to be? Perfect. It's 12 inches, and we get that because it's 20 all the way across here, which means it has to be 20 all the way across here, and we subtract out the 8. So 20 minus 8 gives us the 12. Good. So that area is 16 inches times 12 inches, which gives us 192 inches squared. Now for piece 2, we know that this is 8 inches. What's this? You get 11 inches. And again, that's because if this is 16 here, this has to be 16 here. Subtract the 5. 16 minus 5 gives us 11. So that area has to be 8 inches by 11 inches, or 11 by 8, it doesn't matter. Give us 88 inches squared, which adds up to 280 square inches of area. That is the first way of finding area when we have non-standard shapes like that. The second way is to find the larger area and subtract the missing pieces. What do I mean by that? Well, I would look at this whole rectangle without the corner missing. That is 20 by 16, or 320 inches squared. And then I have to subtract out the piece that's missing. That is a 5 by 8 piece that's missing. Which subtracts to give us 280 square inches. So we'll get the same answer either way. In a problem like this, it's about the same amount of work either way. There are some that are easier to do one way than another. So looking at this one actually would be about the same amount of work either way. Either way, we have some missing dimensions we need to find. So I'm going to do this one by chopping it up. Now, one of the first tricks in chopping these up is seeing how to chop them up. Now, there are other ways. We could have cut it sideways here. Would have worked just fine. So piece 1 here, do I know all the dimensions I need to find its area? Yeah, it's 8 by 20, right? Or 20 by 8, however you want to look at it. 160 inches squared. Piece 2 here. Don't really have any of its dimensions, do I? But we know that the opposite sides of a rectangle have to be the same. So if that's 20, this has to be 20. So if that whole thing is 20, this piece has to be 14. 20 minus 6. The same going this way. If I imagine this as being a full rectangle, or I can imagine it being a rectangle across there is probably simpler. I know that this 22 here has to be 22 across here. And since I know that this is 8 across here, this piece has to be also 14. 22 minus 8. Anybody have any questions on where the 14s come from? That's a skill that in recent years a lot of people have started to struggle with. So don't be embarrassed if you have a hard time with it. Please talk to me and we'll make sure you try to help you figure them out. So that area is 14 by 14. Or 196 square inches. And finally, we got piece 3 here. We know this is 12. How about this length? Yeah, you're right. We know it's 14 all the way across here, right? Because it's 14 here. If this piece is 4, 14 minus 4 makes that 10. So if you didn't have this one right, you weren't going to find this one. So that gives us 12 by 10 is 120 square inches. So we add that all up, we get 476 square inches. Any questions? My math lab likes to do some weird things. Occasionally it jumps ahead and does some stuff that we haven't covered yet. And there's an example. One of the problems in there, if I remember correctly, uses some things that we haven't quite covered yet. Let's say we've got a room that's 15 feet by 21 feet. And we're going to cover it with carpet. And it asks how many square yards of carpet is it going to take to carpet that room? Well, if you look at the dimensions are given in feet. So in order to get square yards, we have to have those dimensions in yards. Can anybody tell me how many yards are in a foot? 3. So 15 feet becomes 15 divided by 3, 5 yards. And 21 feet becomes 21 divided by 3, or 7 yards. So then the area, 7 yards times 5 yards, is 35 square yards. A lot of people want to multiply the feet together first and then convert it into yards. And that does work if you do it correctly. The problem is most people don't do it correctly. You can't divide square feet by 3 to get square yards, because it's not feet anymore, it's square feet, and there's a difference. So the conversion factor is different. And that's something we'll look at more in Unit 4 of the class, when we start talking about measurement and areas and volumes and that stuff. That is it for new material. Because there was a test last class, there is no new quiz, but there is a new homework due for Wednesday. So the computer lab next door is open for you if you want to get started on your homework. I've got about 27, 28 minutes. So you should be able to get a really good start on it if you want to. I'll be around to answer questions. Otherwise, we'll see you on Wednesday.